Hello all, welcome to the channel. So in the previous lecture we have discussed about the equation solvable for y. In this lecture we are going to discuss about the equation solvable for x, right? So solvable for x. So right here we have the same condition as the previous one but with a different scenario. Like, let me explain. Suppose the differential equation f of x comma y comma p. Wait a minute. Right, f of x comma y comma p equal to 0 is solvable for x, then it can be written as, let us compare first of all. Like here what we have, if we have equation solvable for y, then we have okay, leave it. So then we have f of x comma p, right? Y equal to f of x comma p. But here when equation solving for x, so here what we have is x is equal to f of y comma p, because we are solving the equation solvable for x. So now differentiating with respect to y is first equation, differentiating with respect to y, so it is dx by dy equal to what, 1 upon p, because it is same as dy by dx, right? So 1 upon p, which is equal to phi of y comma p comma dp by dx, not dx, it is dy, because we are differentiating with respect to y. So now again, which is a differential equation in two variables, namely p and x. It is differential equation in namely p and y, sorry. So now what we have is, in the same as in the last situation, suppose its solution is f of I comma p comma c equal to 0, where c is an arbitrary constant. Is an arbitrary constant, and the required solution is obtained same as previous one. The required solution, so let me first of all mark the equations. This is first, this is second, and this is third, right? So the required solution is obtained by eliminating the required solution obtained by eliminating p between 1 and 3. 1 1 and 3 के in between, if we eliminate p, then we can obtain the required solution, right? As we discussed in the case for x, similarly we can solve case of y. Similarly in case of x, the same situation applies, but the equation 3 is different as compared to the situation in x. And equation 2 is also different, and equation 1 is also different little bit, because we are dealing with the solvable for x conditions, right? So here, similarly, if elimination is not possible, similarly if elimination is not possible, then what we have, then we can find the values of y and p, or y and x, right? Values of x and y and x in terms of parameter p, and then together constitute found from 1 and 3 in terms of parameter p, parameter p be found from 1 and 3, be found from 1 and 3, then these together will constitute, these together will constitute the required solution, right? So let me again explain the thing. If this is the case of x equal to f of y comma p, so then they differentiate x with respect to y, then dx by dy equal to 1 upon p reverse of dy by dx is equal to phi of y comma p comma dp by dy, then namely, and this again is a differential equation, right? So this is a differential equation of namely the variables p and y. Again, suppose the solution of the differential equation is f of y comma p comma c equal to 0, right? So its differential equation, second differential equation solution is f of y comma p comma c equal to 0. Then we can see that the required solution is can be obtained by eliminating p from 1 and 3. And if I are able to eliminate p from this equation, f of y comma p and f of y comma p comma c, if I eliminate p, then we can directly obtain the solution of the required differential equation, right? About differential equation, sorry. So here we have simply the solution, and by eliminating p from 1 and 3, and if suppose we are not able to eliminate the variable for p from 1 and 3, then we can express in the terms of x and y, and these values of x and y uh, can be eliminated. Values of x and y in terms of parameter can be found basically. So what is the situation? Then we can easily find the values of x and y from in terms of parameter p in terms of parameter p. So whatever we have to express the values of x and y in terms of p, which can be easily done. So, and once they done, can be found from 1 and 3, and the values of 1 and 3 can be found in terms of parameter p of x and y. Then from the 1 and 3 it could be found, and then once the value will be found, then this together will constitute the required solution, means the required this together will constitute the required solution here. So I hope this is clear. Now moving forward, we will solve some question in the upcoming lectures, and have a nice day. Thank you.